Number five. I think I duplicate this one. Number five is here. Yeah. Number five is alcohol to carboxylic acid or to carbonyl. Yeah. All these reactions are called something oxidation. Oxidation reaction. And you have this thing here. Alcohol to carbonyl, carbonyl to carboxylic acid, or alcohol directly to carboxylic acid. And what is carbonyl? Carbonyl is either aldehyde or ketone. Yeah, either aldehyde or ketone. So you can. And for oxidation reaction to happen, you need an oxidizing agent. And the symbol for oxidizing agent is this square bracket over here. Yeah, means is oxidizing agent. And for organic, there are a lot of oxidizing agent, but the common one, the two common one, what are they? KMNO4, potassium permanganate. If you use that, the color will change from
purple to colorless.
very good. The other one is potassium dichromate. This one also must memorize. So either one will do. The color change from orange to green.
Okay.
Yeah.
Okay.
Then there are several possible reaction. Yeah. The first one is alcohol. We call it 5A. Yeah. Primary alcohol. You add oxidizing agent, then you get aldehyde. I give example. Propane 1-ol. Propane 1-ol plus square bracket O like that. Yeah, oxidizing agent. Okay, right on. Then give me the product. Propane 1-ol. Yeah. Okay, try. I'll check something. You don't know? Very simple. Is you're going to get propanol. This is an aldehyde. Yeah. This is called propanol. How do you know that is primary alcohol? This carbon here, this carbon that contain OH. Sorry, this is OH. This is the carbon that contain OH. Contain this H. Have only one carbon change. We call it R group or alkyl group. Yeah. This is called primary alcohol. Then you're going to get like this here. Yeah. Propanol. We call it propanol. Second degree alcohol. Try butane to all. Butane to all. Then, by the way, what I mean by carbonyl compound is aldehyde and ketone. Both aldehyde and ketone, we call it carbonyl. Yeah. Okay. Butane to all. Correct. Yeah. So how do you know it's second degree alcohol? This carbon connected to two R group. Yeah. This is R1, R2. Like this. Yeah. This one also R1, R2. What's the name here? Ketone. How do you give name? Butanon.
Oh,
Butanon. Yeah. Okay. Then five. Okay. Good. Butanol. Butane to all become butanon. 5C is third degree alcohol plus oxidizing agent. What will happen? No reaction.
oh, why not?
Why? You try. You try. Oxidation of 3-methyl pentanediol. Yeah. If you write it, then you'll see the why it doesn't work. You know how to draw?
No.
Write down the name. 3-methyl pentane triol. Then you draw the pentane. You draw pentane, and on carbon number 3, you draw a branch.
Oh.
Yeah. On carbon number 3, you draw a branch of one carbon. Yeah.
Then where does the OH?
OH are also on carbon number 3 because it's pentane 3L.
Like that?
Yes, correct.
Oh.
Input OH. Then is third degree alcohol or tertiary alcohol because this carbon is connected to 3R group. R1, R2, R3. Try. You add the oxidizing agent. Try draw the product.
Is it because the middle carbon will have like 5 bonds?
Yes, correct.
Oh.
Draw the wrong one.
Okay.
Draw the wrong product. Yeah. So that's why it's wrong. Yeah. That's why it's wrong. Yeah. Okay. Then 5. So 5D. Aldehyde. Aldehyde itself, you can oxidize to become. Oh, by the way, when you do this, you have water as byproduct. Understand? Because you're removing the H.
Okay.
Understand? So aldehyde plus here become carboxylic acid. Try oxidation of butanol. Yeah. Yeah. Aldehyde means the OH on the end. You don't know aldehyde, the structure of aldehyde. Aldehyde is something COH like this.
Oh.
Ketone is you have left and right here. This is aldehyde. This is ketone. Carboxylic acid, of course, you know. This is carboxylic acid. Yeah. Oh, sorry. Yeah. Yes, correct. Write down the name. What is the name? Yeah, yeah. Butanol, you get butanoic acid. Yeah, correct. Then correct. Then 5E. Oh, yeah. Ketone plus oxidizing agent. What will happen? Nothing. Yes? Agree?
Oh,
You
okay.
try?
Okay.
Try pentane trione plus oxidizing agent.
Pentantrione.
On, which means it's a ketone, which looks like this. But the double bond O is on carbon number 3. Yeah. And then trione, if you oxidize, try right on become go copy and you put OH, yeah. Or we copy here. Yeah. like this. Yeah, and this is wrong. Yeah, that's why it doesn't work. Yeah. Okay, 5F is primary alcohol. You oxidize, and then it will go directly to carboxylic acid. This is the one that we learned in sector. Yeah. Okay. Oxidation of propanol, propane 1-ol. Yeah, correct. Now, okay, so the diagram here, the diagram for this reduction, for this oxidation here is here. If you look at it here, primary alcohol. Oh, the numbering is different. The labeling is different. Okay, now primary alcohol can turn, you oxidize, you get aldehyde. Aldehyde can turn to carboxylic acid. Yeah, can. So that's the reaction. How about secondary alcohol? Secondary alcohol, you oxidize, you get ketone. Ketone, you oxidize, nothing. You cannot oxidize ketone. Yeah, that's how you prove. Then tertiary alcohol, you oxidize, nothing. We prove that also. Phenol also. Phenol, you cannot oxidize. Yeah. Now, one very important question here. Primary alcohol, you oxidize, there's two possibilities. One goes to aldehyde, one goes to carboxylic acid. What is actually happening? Does the two reaction happen together? That means if I oxidize alcohol, you get a mixture of aldehyde and carboxylic acid. Is that what happens? Or you can tell, you put alcohol, then you give instruction to the alcohol. I want you to turn to aldehyde. Can you do that? You can't, right? So what happens? What happens? What really happens is actually you get a mixture if you don't control it. Yeah. If you want to control it, there's a way, there's a procedure for you to go into. Sorry. There's a way for you to get what you want, whether you want it to be carboxylic acid or this thing. If you want to turn it into carboxylic acid, you use this process this process is called reflux. You have a condensing, this one is fractioning column in the middle. Oh no, not fractioning column. You just put bits here, glass bits here. So this reflux setup is like this. You put alcohol and the oxidizing agent. You heat it up. Maybe you use Bunsen burner below. Then it will react. It react. You get a mixture of carboxylic acid and aldehyde. Then the aldehyde wants to go up here, and you push them because it will cool down. It will cool down back, cool back, and go down, condense again. Then it will go again here, go down again, and react again. So any aldehyde you have will be forced to convert to carboxylic acid. Yeah. So this process is called reflux. This is if you want to have carboxylic acid. Yeah. Will it be pure? Is almost 100%, but it's not 100%, but it's almost pure. Yeah. What if you want this thing? What if you want aldehyde? Then you use this process. This process is called immediate distillation. Immediate distillation. What will happen? You have something here. You heat up, then you put fractioning column here. Then the aldehyde, don't let it go back. Instead, you put here, then you condense. So the aldehyde don't have a chance to react further to become carboxylic acid, but you quickly remove it. Then you get the distillate, and the distillate is aldehyde. Yeah, the temperature you adjust slightly higher than the boiling point of the aldehyde. Correct? So that the aldehyde go up, and when it condenses, then it will, you take it out. Yeah, you remove them. Yeah. So like that. See, we learn a lot. It's a lot, you know. We are very quick. Yeah. Okay. One. Okay. Oops. Hey. Okay, I shift here. Then number 6. Number 6 is reduction. Yeah. If you look at it, yeah. 6 is the opposite.